Yes.
Hello everyone, welcome to the second session of Tribology 17ME742. Today we will start with the module 1 Introduction to Tribology. As we have seen in the previous session where we have dealt with the complete brief syllabus of Tribology, where I just highlighted what are the things that we will be seeing in the first module, that is Introduction of Tribology. In Tribology, let us start with the definition of Tribology. Tribology is derived from a Greek word tribos, which means rubbing. Tribology is derived from a Greek word called tribos, which means rubbing, and which includes all the science and technologies and the knowledge of the surfaces interacting between each other, and also which are coming in relative motion with each other. So tribology is derived, the term tribology is derived from a Greek word tribos, which means rubbing, The rubbing will happen only when there is a relative motion between the two surfaces which are coming in contact with each other. So, and the science that is present in relative motion as well as rubbing is completely studied in tribology. So, tribology is having a three complements or three members, that is friction, wear and lubrication. So, tribology is composed of friction, wear and lubrication. So, the tribology is an art to minimize the economy of any industry or minimize the losses that are incurred for an industry, like to minimize the maintenance cost, to increase the reliability of the machine component, and to minimize the friction, thereby eliminating the wear. That's done with the help of lubrication. So, tribology is composed of three things: friction, wear and lubrication. So, once if we understand what is the tribology, the machine component that is designed or that is used in an industry can be used more accurately without any much errors, like friction. If we have more friction, so which will result in wear of the components that are present coming in contact with each other. So, if the wear is present in the components, that adds up to replace the component that is always getting weared off. So, the cost that is incurred to replace the component is additional to the company. So, we are supposed to make the components less wear and tear. This can be done by adding something called as a third member called as lubrication. So, the lubrication, when we call lubrication, we have different types of lubrication. We will come to know what are the types of lubrication in the coming classes. So, this is what the thing about the tribology. Now, let us understand how the tribology has evolved. Tribology is quietly a new subject, but new subject which is came into existence, came into awareness to the society only after 1966, but that doesn't mean that tribology was not there till then. It was used by our ancestors in different varieties, but they didn't call that by the word called as tribology. Like if you remember the grinding of cereals and the potter who used to turn the wheels also used some relative motion between the contact two surfaces. There actually the tribology was present, but the ancestors were not knowing what is happening, and our ancestors used some adhesive or some adhesive materials or some lubricating materials to minimize the friction that is happening in case of translatory motion. You can take an example of a wheel, car to wheel, all those places they were using some oils, they were using some adhesive materials to minimize the friction. There they used, without knowing they were using the lubrication terminology, but they couldn't identify. That's tribology. But Leonardo da Vinci, he came and he proposed the word tribology, and he proposed one more concept called as coefficient of friction. He introduced a new term called as coefficient of friction that exists when a square block slides over the another flat surface. When the block slides over the flat surface, the block experiences some amount of resistance for motion. This resistance of motion is present because of the surface roughness of the flat surface on which the block gets slided. So, then because of that friction, he introduced a concept called as coefficient of friction, which is nothing but the frictional force divided by the normal area. Frictional force divided by the normal load. Sorry, normal area, normal load. Coefficient of frictional force, coefficient of friction equals frictional force divided by the normal load. So he proposed that concept, but unfortunately that didn't come into exposure to the society even after 1966. Then one more scientist by the name G. Amontinus, he enhanced the work of Leonardo da Vinci. He continued the work of Leonardo da Vinci, and he discovered other two laws where he proposed the coefficient of friction is directly proportional to the frictional force. Frictional force. That means frictional force is directly proportional to the normal load that is acting, and that proportionality constant is taken out by the coefficient of friction, symbol called as mu. Also, he extended his work, and so that he said the frictional force not only depends on the coefficient of friction, not only depends on the frictional force, but also it depends on the surface area of contact and the asperities that are present on the flat surface. These are the extensions that is done by Amontinus. So he is generally credited with discovery of two laws, that is first law of friction and the second law of friction. So this is the history of our tribology. You can still, if you just start thinking, we have lots of examples to say that the tribology was used by our ancestors, like the fire that they were producing to ignite a stove or to cook anything. They were just tapping two stones to get the fire. Also, you can just look into, when you see some NGC, National Geographic channels documentaries, you have seen some people, they are generating the fire by just drilling two surfaces. That is, they will rub the wood surface on the other surface. They produce the fire. So our ancestors were using the tribology parameters, but they couldn't identify that as tribology. So this is the history of our tribology that is got into existence from 1966 with the help of Leonardo da Vinci, but it was still more explained to the society by G. Amontinus, who proposed two laws, but it doesn't mean that our tribology came into existence only in 1966. It was under use by our ancestors for different applications. So as I said, potter used to potter wheels as well as stones used for grinding cereals, all those things where the surfaces were coming into contact, so there were lots of wear and tear happening and so on. So this is the brief, a small introduction to our tribology. So I will just brush up a small thing. Tribology is derived from a Greek word called as tribos, which means rubbing, and it includes all the science and technology of interacting surfaces in relative motion with each other. Then tribology is having a family of three members: friction, wear and lubrication. The main aim of the tribology is to avoid wear by reducing the friction with the help of lubrication. Avoid wear by reducing the friction with the help of lubrication. We have different types of lubricants present in the market. We will see what are the types of lubricants available in the coming sessions. Then the history of tribology, it dates back to 1966. It was proposed by Leonardo da Vinci. He proposed the coefficient of friction is a ratio of frictional force divided by the normal load, or frictional force is directly proportional to the normal load. And he explained that concept by taking a square block or a block moved over the flat surface. Then his work was extended by G. Amontinus, who said the surface area of contact is also very important while considering the coefficient of friction. Okay, so we were seeing the history of tribology. As I mentioned, the tribology was announced by Leonardo da Vinci in 1966, and Amontinus extended his work and he proposed two laws according to Leonardo da Vinci. In continuation to Amontinus, so other few scientists were also contributed in a huge to tribology. So one such scientist was Augustin Coulomb. I hope everyone might have heard of Coulomb's dry friction or Coulomb's law of friction. Yes, he is the same person, Augustine Coulomb. He proposed the third law of friction. He stated the frictional force is independent of velocity. If frictional force is independent of velocity once the motion is started between the two surfaces. That means to say, at the beginning of the motion of the surface, the friction is high, whereas once the member starts picking up the speed or starts picking up the velocity, the friction between the two mating surfaces comes down, and hence based on these experiments he stated the frictional force is independent of velocity once the surface velocity has, once the member has started its motion. And Augustine Coulomb is the one who distinguished clearly between two concepts, that is kinetic friction and static friction. He distinguished both static friction, the friction that is resulting at the beginning of the mating surfaces or the moving surfaces. Kinetic friction, the friction which is resulting because of the motion during the motion. So he clearly distinguished between the two types of friction that is present in our tribology as kinetic and static friction. Then once the friction is present, obviously there is a wear of a component or wear of the one of the block. So how to minimize this? How to minimize this? What are the postulates? What are the postulates we have? Does anyone contributed to minimize this in those days? Yes, obviously there were lots of members who contributed to minimize this friction. So I hope everyone might be knowing Newton's law of viscous flow. Newton's law of viscous flow. So viscous flow, the fluid, viscosity, viscous medium. So Newton's law of viscous flow helped a lot for Towers as well as Reynolds to enhance the tribology concept, to minimize the wear happening between the two relative motion between the two surfaces. So in this, the Petrovs and Reynolds conducted the theoretical work of tribology, whereas Tower conducted an experimental work. In his experimental work, he understood the hydrodynamic lubrication principles, in which he used the laws of friction, viscous laws of fluid, which was postulated by Newton, which was postulated by Newton. In his experiment, he understood the basic principles, basic working principle of an hydrodynamic lubrication, where when the fluid behaves in laminar flow, when the fluid is in turbulent flow, when the fluid is in transition flow. What is the effect of these regions for the wear, and how the wear and the friction can be minimized by the use of this concept was done by Towers. He conducted a huge experiment. In further classes, we will see how the Towers conducted an experiment. We have a concept called as Towers experiment. In our further classes, we will discuss his experiment in detail. And the theoretical interpretation of Towers experiment was done by Petrovs and Reynolds. I hope everyone knows the Reynolds number defines how the fluid is behaving, whether it is moving in a laminar condition, or it is in turbulent zone, or it is in transition zone. So, Reynolds concept gave an idea for Tower to select what state of the fluid I should select, whether we are dealing in a laminar condition, turbulent condition, or in transition condition. Petrov made use of both Towers and Reynolds concept, and he gave an expression for coefficient of friction. The expression is very famous, Petrov's equation of friction. He introduced that Petrov's equation for friction for lightly loaded bearings. Everything is detailed for hydrodynamic lubrication, where the fluid is used as a lubricant between the two mating surfaces. So these were the developments that happened in the tribology. It started in 1966 by Leonardo da Vinci, and it still continues. Even till date, many of the scientists are working in the field of tribology, like how to minimize. All the scientists around the world, they are working on different types of materials, the wear resistance materials, how to minimize the wear, and they are working on different type of lubrication. Like nowadays, they are using the lubrication of edible oils, synthetic oils. See, I hope everyone might have used the synthetic oil for our engine oil for two-wheeler. So synthetic oil as well as regular oil has got different characteristics. So use of synthetic oil will give a service life more than that of a normal oil. These are the developments still happening in the field of tribology. So so it is a never ending topic, because in any industry if you take, they requires a maintenance department will be there. In that maintenance department, they are worried about the lubrication of a components, lubrication of a machine elements. So the lubrication is very important, and wear and tear will be there, and our being a tribologist, it is very important duty of us as well as a maintenance engineer how to minimize the wear and tear of a component. Obviously that can be done only with the help of lubrication, or by developing a material which has got good wear resistant characteristics with good wear resistance properties. These are the developments that still happening even today. So with this we will end up with our history of tribology. Then in the next session we will see what are the importance of tribology in the society as well as in the industries. Okay, hello everyone. Let us continue with our discussion on introduction to tribology. As we have seen, the tribology is an ancient subject, and it was introduced to the society in 1966 by Leonardo da Vinci, and we have seen the effect of coefficient of friction, how the coefficient of friction came into existence, and what are the developments that taken place, and how the experimental work has carried out by Tower, Reynolds, and so on. So today let us see the importance of tribology in the field of industries, how the tribology is important in the industrial applications. Yes, tribology has got huge influence on the industries, because there are some positive impact of friction and wear happening in the industries, as well as there are some negative implementations that's happening. So tribology in machinery components is very important, because there involves lots of sliding actions, rolling actions, and so on. So in industries, as we use lots of machines, so tribology and its combinations like friction, wear, and lubrication play a huge role in the modern machineries. As we have seen, the sliding actions in lathe and rolling actions in case of a bearing and cams all get affected because of this wear and friction that is coming because of the relative motion between two surfaces, which may have and may have some rough surface or some foreign particles that are present on those surfaces. So if you go further, if you come to see an automobile or an vehicles, brakes, clutches, and wheels, chain sprockets, bolts, nuts, screws, wherever we have some contact surfaces happening between the two members, there we come across some wear and tear. Obviously, you might have seen after running so much number of kilometers, our servicing garage person will inform us to change the brake bush or the brake pads. That means to say the brakes pads have got weared off. Then this wear is nothing but the part of a tribology. So nuts and bolts, we might have seen the bolt and the nut is getting loosed, and this is happening because of vibrations that is created in a vehicle, and that small vibration or small disturbance that is causing will remove a small particles due to etching, by small size particles will be removed on that nut, and this also is a part of tribology. All these are the huge give a huge influence in the modern machineries as well as the vehicles that we will be using. So these two, what we have seen, the modern machineries where sliding, rolling, and so many activities are going to happen, nuts and bolts, brakes, clutches, and so on. These are the negative part of the wear as well as friction. But there are some advantages of friction, where the friction is treated to be as a positive way, because without the friction we cannot do some of the activities like writing on the board. See, I am going to use a chalk paste, and something that is written on the board, this is visible to you only because of the friction that is present. The chalk paste is softer compared to that of the board that is on which I am going to write. See here, the chalk paste has lost some amount of material, and the board has given some amount of resistance. If this friction was not there, then there was a slip that is happening, we couldn't have written on the board which is visible to us. So here friction is a positive, it is an advantageous thing. That is, in a productive manner, we can see the friction in a productive manner. Writing something on a paper, writing something on a board with the help of chalk paste, erasing the things where we use a eraser get weared off, whereas the mistakes that we have done on the paper will be erased. So the eraser. So these are some of the parts where the friction is taken as a productive way. There are some other unproductive friction present in the machine components, like in an engine, the piston and the cylinder. The piston and the cylinder, usually we get after around 60 to 70,000 of kilometers of running of a vehicle, our the engine gets bored, comes to bore, where there is a wear happening in case of a engine cylinder. This has to be replaced. See, again, gears get weared off, chain sprockets get weared off. See, these are the unproductive behavior of the friction and the tribology. So these are the importance of tribology, and we should also observe, because of friction present between the two surfaces, lots of energy is going to be wasted, which is lost. So it is predicted, or it is estimated, that in the total world's energy, 1/3 of the energy is lost only due to friction. It's a huge loss to the industries and huge loss to the machineries, huge loss to the society. So not only we are losing the machine components, but also some of the economical aspects are also going to be hit, because I need to go for frequent inspection, frequent maintenance cost is going to be incurred, breakdown is going to happen in the machine components, which requires frequent servicing of the machine components. Everything is associated with the finance, and economy is also going to be hit. So it is very important to observe this term, that is 1/3 of the total world's energy is lost only because of friction. Our work is to try to reduce this loss of energy because of friction. So our work is to try to minimize this. In today's research in tribology, the lots of research happening in the tribology are aiming to bring down this loss due to friction, and which increases in plant efficiency, which will increase the production, which will minimize the breakdown of the machineries, which will bring down the servicing happening to the machine components. So thereby the performance of an industry as well as the efficiency of the industry or a machinery is going to be enhanced with research that is happening in the field of tribology. Then if we come, how are we going to minimize? We are going to minimize this by taking certain precautions, like we will select such a material which will be having a wear resistance, and if those materials are not selected in a proper way, then we have one more option. We have a lubrication that is coming to picture. We need to lubricate the components perfectly with a frequent inspection, with a frequent continuous inspection is to be taken care. So lubrication is an art of reducing the friction resistance between the two surfaces that are coming in sliding motion or rolling motion. So lubrication is a very important parameter, very important thing in our tribology, which tries to minimize the losses or the effects that are produced because of friction and the wear. So there are some other terms associated with the lubrication. We will see this, the effects of lubrication, and see the properties of oil or the lubricant. So the one very important property of an oil is the viscosity. Viscosity. What is viscosity? Viscosity of a liquid is the ability of it to resist a change in shape. It is the ability of a fluid to resist the change in shape, and this resistance is because of the internal resistance, and it is a molecular phenomenon. It is a molecular phenomenon. So viscosity is the ability of a liquid to resist the change in shape. The ability of a liquid to resist the change in shape, and it is the molecular phenomenon, and this is because it's the resistance shown at the internal, it is the internal resistance shown by the liquid for the motion or the movement. So with the help of this viscosity, and as we have seen in the history of tribology, Newton contributed a lot to tribology with the help of his Newton's law of viscous flow. Let us know what is this Newton's law of viscous flow, and what are the terminologies, what are the statements that is given by the Newton. So the Newton's law of viscous flow states that at any point in a fluid, the Newton's law of viscous flow states that at any point in a fluid, the shear stress, the shear stress is directly proportional to the rate of shear. Newton's stated that according to the Newton, the viscous flow, Newton's law of viscous flow, at any point in a fluid, the shear stress is directly proportional to the rate of shear. Shear stress is directly proportional to the rate of shear. Let us understand this concept with the diagram which is represented here. Here we have considered two parallel plates. One stationary and another one is the moving plate. The stationary plate is at the lower as well as the moving plate is at the upper level. So we make certain assumptions in this law. That is, there is no vertical load acting on this moving surface. And the stationary surface is completely fixed. There is a fluid that is filled between the moving surface as well as the stationary surface. That means the gap between the moving surface and the stationary surface is completely filled with oil or the lubricant. This gap is represented with H. That is the thickness of the fluid film or the thickness of the lubricant that is present between the two parallel plates. Here, the lubricant that is present between the parallel plates get adhered to the surface, get bonded to the surface. That is, the fluid that is very closer to the stationary plates get adheres to it, and the velocity of the fluid very closer to the stationary plate is 0. Because the stationary surface is at resting condition, that is, it is fixed plate, and the velocity of the fluid very closer to the stationary surface is 0. Whereas the fluid or the lubricant that is adhering to the moving surface will have a velocity equal to that of the velocity of the moving surface. That is, if the moving surface is moving with a velocity of u, the fluid that is adhered to this moving surface will also have a velocity of u. You can just observe the diagram. We are applying some force on the moving surface, thereby the plate or the surface will be pushed forward or it will be pulled forward, and the velocity at which this moving surface will be possessing the fluid or the liquid or the lubricant adhering to this moving surface will also have the same amount of velocity. With this, so let us understand what is the Newton's law of viscous flow. So Newton's law of viscous flow states that it is said that the rate of shear stress is directly proportional to the rate of shear. Let us denote the shear stress with tau. As I said, it is with respect to the velocity and the distance. So any point, if we consider any point between this the moving surface and the stationary surface, the velocity of the fluid at any given point is the function of the distance between the moving surface as well as the stationary surface. So the distance between the moving surface and the stationary surface is h in our diagram. So let us call tau as the shear stress and du the small elemental velocity of a moving fluid at any given point, at any given location, and let dy be the distance of the fluid which is considered from the stationary plate. So tau, we have removed this proportionality constant, the shear stress directly proportional to the rate of shear. We have removed the proportionality constant with the help of proportionality constant, and that constant is called by the term absolute viscosity. We said already, viscosity is the ability of a liquid to resist the change in shape. So that resistance in change in shape is represented by neta, which is called as an absolute viscosity. So du by dy is nothing but rate of shear, which is rate of change of velocity with respect to the distance y or the height y. So du represents the small velocity, whereas dy represents the distance at which we are considering the fluid or the liquid or the oil for our derivation. So du by dy. So we know the velocity of the moving surface is u, then the distance we call it as y. So du by dy can also be represented by the velocity and the distance between the two surfaces, two parallel plates, that is h. So thereby rearranging the above equation, we can get tau is equal to neta, whereas du by dy can be written as u by h. Tau equals neta into u by h. So this is an expression for shear stress that is induced in the fluid that is flowing between two parallel plates. Then we can rearrange this equation to get an unknown, that is absolute viscosity. The absolute viscosity can be found by rearranging the equation, that is neta equals tau h by u, where tau is the shear stress, h is the distance between the two parallel plates, u is the velocity at which the moving surface is floating or moving forward. So we know shear stress, we know stress is nothing but force by area, and shear stress is nothing but shear force divided by the area. Shear stress is given by force by area, where area A is the plane surface area which is coming in contact with the lubricant, that is the surface area which is in contact with the lubricating oil. That is, if we consider two parallel plates, this area is taken as the surface area which is coming in contact with the lubricating oil. This gap is completely filled by the lubricant or the oil. So the area which is in contact with the lubricating oil is the area which we will consider for our shear stress. So shear stress tau is equal to F by A. So we know neta, we know neta, which is given by tau h by u. Let us substitute tau as F by A into that equation. Therefore neta equals F h by A, F h divided by A into u, where F is the force that is applied on the moving plate, h is the gap between the two parallel plates, A is the area of contact of the lubricating oil and the moving surface, u is the velocity at which the moving surface is moving from one point to another point. Let us know what is the unit of this absolute viscosity. We know the unit of force, we know the unit of height, we know the unit of area, we know the unit of velocity. Let us deduce the unit of absolute viscosity. The unit of force is Newton, the unit of height is meter, the unit of area is meter square, the unit of velocity, that is meter per second. So we have reduced this into our dimension with the help of our dimensions. So meter get cancels. So we will end up with Newton second per meter square. Newton second per meter square. This is the unit of absolute viscosity. So from our basics of mechanics of materials or strength of materials, we know something Newton per meter square is called by Pascal, So we can replace Newton per meter square as Pascal, and second we can retain the same. So the unit of absolute viscosity can be called in two ways, that is Newton second per meter square or Pascal seconds. So this is what the Newton's law of viscous flow states. So this is a very important part, basic part of our tribology in our first module, which will be asked for 8 marks in our examination, like state Newton's law of viscous flow and reduce the expression for absolute viscosity with usual notations. So we will see how the viscosity of a fluid is measured with the help of different measuring instruments, and what are the effect of temperature and pressure on the viscosity. So we will be dealing with those two concepts. Okay, let us continue our discussion on viscosity. We have seen the Newton's law of viscosity and the definition of viscosity. So Newton's law of viscosity states that shear stress is directly proportional to the rate of shear, and we have seen an expression for absolute viscosity also. Now let us see what are the effects of temperature and pressure on viscosity. So let us first look into the effect of temperature on viscosity. So the viscosity is is due to the intermolecular forces between the intermolecular forces within the lubricating oil. As the temperature increases, the intermolecular forces within the lubricant get loosened up. As the intermolecular forces get loosened up, the viscosity of an oil keeps on coming down, that is keeps on decreasing. Hence, the viscosity of an oil decreases with the increase in temperature. The viscosity of an oil decreases with the increase in temperature because of the weakening of intermolecular forces with the increase in temperature. So, the change of viscosity due to change in temperature is different for different oils. The rate of change in viscosity is due to change in temperature, and this viscosity is different for different oils at different temperature. At the same temperature, two different oils will have two different viscosity. Two different oils will have two different viscosity because the two lubricants will have two different intermolecular forces, and as these two intermolecular forces are going to get weakened up because of the increase in temperature, their viscosity is different at different temperature, and even at same temperature the two oils will have different viscosity. Now let us take an example. I have taken a same lubricating oil, but I have kept at two different temperature. What will be the viscosity of oil A and oil B? Sorry, I have taken two similar oils, oil A and oil A, but the temperature is different. This is kept at 80 degrees centigrade, this is kept at 60 degrees centigrade. Since the temperature is different, obviously the viscosity at that particular instant of time is different for these two oils, even though the oil is same. So based on this, so the expression for absolute viscosity is framed, that is natural logarithmic of absolute viscosity equals A plus V by T, where A and B are the constants and T is a temperature, it is the absolute temperature. So when we plot a graph for different oils along x-axis as a temperature and y-axis as a absolute viscosity in terms of centistokes. So when we have plotted for three different oils, that is SA 40, 50 and 60, as you can observe, as the temperature increases, the viscosity of an oil comes down. Viscosity of an oil comes down. This is the effect of temperature on viscosity. So in brief, if we summarize the effect of temperature, as the temperature increases, the viscosity of an oil decreases. So this is the effect of temperature on viscosity. Let us see what is the effect of pressure on viscosity. As I said, viscosity of an oil depends on intermolecular forces that is present in the lubricant. Again, the same intermolecular forces are also affected by the pressure. As the pressure increases, the intermolecular forces are forced, and the bonding between the lubricating molecules present in the lubricating oil are still forced, and the molecules come closer to each other, and the fluid becomes more thickened. So as the pressure increases, the viscosity of an oil increases, because the intermolecular forces between the molecules are increased. So this is the effect of pressure on viscosity. So based on that, so we have formulated, the scientists have formulated based on the experiments as neta equals neta naught into exponential alpha into P, where neta is the absolute viscosity and neta naught is the absolute viscosity at atmospheric pressure, and P is the pressure at which the lubricating oil is subjected for is under the pressure. So these are the two effects of pressure and temperature on viscosity. We can observe from the graph, as the pressure increases, where we have pressure on one coordinate and viscosity on the other. We see as the pressure increases, the viscosity of an oil increases. That means to say, as the pressure is increased, the resistance offered for change in shape of an oil or change in shape of the fluid, it keeps on increasing. That is, it shows huge resistance for free flow of the fluid. So this is the effect of pressure on viscosity. The entire thing is represented in the figure.